All right, everybody. 654, writing polynomial equations now with imaginary roots. So we're going to finish up section 6.5 with these notes. So it's, in my opinion, simpler than the 6.5.3 notes where we were dealing with a lot of square roots. So just to recap what we were doing with that stuff, because it kind of relates to what we're doing here with this new stuff. So if we have polynomial equation with integer coefficients, we have the roots 3 and 1 plus square root of 11. We want to find an additional root. So that means there's only one more additional root. So if we have 3, that does not mean that negative 3 is an additional root, so that's done. But 1 plus square root of 11 means that we have an additional root, because remember, square roots give us an additional root. This is why we put the plus or minus in front of square roots. So 1 plus square root of 11, 1 minus square root of 11 would be our two roots there. So there's the 3, the 2 in blue, and then the red one. So this is the last thing we're doing here in section 6.5. So a plus bi, a minus bi. Again, if they're square roots, those are called conjugates. If we have i's, those are complex numbers, so these are called complex conjugates. One thing that you do need to remember, and just refresh your memory on this, is we also had this idea that if we have I squared, remember I is not necessarily a variable. We know that I is equal to something, and I squared is equal to negative 1. So we do want to remember that, because that will come into play here in these problems. So again, the stuff in the green box, that comes from your textbook. So let's jump down to this example here. Very similar to the square roots, whenever we have i's, we use the opposite sign to get our additional roots. So 3 minus I, if 3 minus I is a root and 2i is a root, that also means that from 3 minus I, we would have 3 plus I. And if 2i is a root, then that means negative 2i is a root. So it's only the I term, the imaginary term from the complex number, that gets the sign change. Okay, so 3 plus I and the negative 2i. And in this example here, if we have 3i, we would change that 3 to a negative 3 to get our other root. And then negative 2 plus I, again, the negative 2 does not change. It's only the plus I that changes to a minus I, so it would be negative 2 minus I for that one. All right, and then just like the notes from 6.5.3, we're going to go ahead and write some polynomial equations. We're going to write a third degree, a fourth degree, and then a third degree again. So what I'm going to do is I'm going to do example 3 and 5, and then I'm going to have you guys try example 4, and then I will put my notes up here for that one and see what you got for that one. So let's go ahead and jump into this one here. So again, if I have roots 3 and 1 plus I, that means I have roots 3, 1 plus I, and then 1 minus I. Okay, so when I write this, I'm going to write it as y equals, they're all going to be x minus the first one, x minus 3, and then x minus the second one. So that's going to be, oops, looks like a plus sign, x minus, and then it's going to be 1 plus I, and then when we distribute that through, it's going to change it to 1 minus I. So usually when I do this, I don't really even, because you end up with all of them here anyway, it just looks like they don't look any different. So like let me just show you here. So if I distribute my negative through here, I get minus 1 minus I. So really what it looks like is, it looks like I just used this one, even though I'm using the first one. So I typically don't even show that step, because to be honest, I don't even show that, because it really just looks like it looks like I just flipped them, and I used the other one in its place. Really, the middle one, like, they're in order. Like, this is first, second, third. This is first, second, third. Even though it kind of looks like they're flipped. But like I said, it really, when you distribute the negative through there, they all come out. But it's not, I don't know. I usually don't even show that, because they're all there. They end up being in a different order. So anyway. Okay, so I'm going to bring down my x minus 3. And then I'm going to start distributing this stuff. I'm going to distribute this one first because this is the more complicated one. The x minus 3 will be much simpler. But if I distribute these two, because these are difference of squares, it will simplify first. And then I'll distribute the x minus 3 through there. So I'm going to start with this one. So I'm going to first of all multiply the x through. So x, multiply that through, so that's x squared. X times negative 1 is just negative x. And x times I is just plus xi. Or you can write ix, that doesn't matter. Next up, multiply the negative 1 through. So negative 1 times x is just negative x. Negative 1 times negative 1 is a positive 1. And negative 1 times I is negative I. And then I'm going to take the negative I. This might get a little messy here. Negative I times x is the negative xi, which is good. That'll cancel with this positive xi. Negative I times 1, that's positive I, which is nice. It's going to cancel with this I right here. And then negative I times I is negative I squared. And if you remember, back on this slide right here, this is why I was saying we need to remember this, okay? I squared is equal to negative 1. So that's why I was reminding you of that. That was something that we had talked about earlier in chapter 5, so we just need to remember that fact. All right, so let's do this part here. Now, xi, like I said, xi minus xi cancels. Negative I plus I cancels. And then what I'm going to do, so I don't have to rewrite this whole step here with this, negative I squared is negative 1. So this part right here just ends up being plus 1, okay, which is going to combine together with this plus 1 right here. So we'll get to that part. All right, so let's bring this down here. So x squared, and then we got a minus x, and another minus x, so that's negative 2x, right? Negative 1 minus 1, that's negative 2. X. And then we got a 1, and then plus this 1 right here gives us plus 2. All right. So now we're ready to distribute the x minus 3 through that part. So let's do this last step here. So x times x squared, it's going to give us x to the third. X times negative 2x, that's negative 2x squared. And x times 2, that's just a plus 2x. And now when we distribute the 3 through, again, we don't want to forget that this negative is part of that. So negative 3 times x squared is negative 3x squared. Negative 3 times negative 2, negative times negative is a positive 6x. And then negative 3 times a positive 2 is negative 6. All right, we got one more step here. Last thing we need to do is just combine our like terms. We have 1x cubed. All right, there's just one x cubed term here, so we bring that down, x cubed. Our x to the second power, we have a negative 2x, negative 2x squared and a negative 3. All right, all we're doing is combining those numbers out front. So negative 2 minus 3, that's a negative 5x squared. All right, and then we have a positive 2x and a positive 6x. Again, add the numbers out front. 2 plus 6, that's all we're doing there. 2 plus 6 gives us 8x. So plus 8x. And then we got this minus 6 all by itself. Nothing to combine with it. Bring that down. There's your final answer. All right. So the next problem, number 4, I'm going to skip over number 4, and I'm going to jump to number 5, and then I'll come back to 4. All right. So again, if you have any questions on this one, you can go back through, rewind, and watch any parts of that. So let's jump ahead. Again, I'm going to come back to number 4. Number 5 is very similar to number 3, so I'm going to go ahead and do this one, and then we'll come back to we'll come back to number 4. Number 4 I think is a little simpler, even though it's a 4th degree. I think it's a little simpler, but it might seem a little more intimidating because it's a 4th degree, but it's actually easier because you don't have the 2 minus I part or whatever. So again, our different parts here, we have x minus 2 minus I, and then we have x minus 2 plus I. All right, and then again, the first part here, I have x plus 1. That's because it was x minus, and then this one right here is a negative 1. So it's x minus a negative 1, which would just change to x plus 1. All right, so if you want to, at this point, if you want to pause the video and then go ahead and follow the steps that we just did in that last example, you can go ahead and do that and just see what you did, because see how you do, because it's very similar to that last problem, okay? It has similar zeros, similar factors. If you want to, just follow your steps you did in that last problem, you can go ahead and do that and just see how you do with it, because you should be able to follow the steps pretty directly and end up with a similar answer. Because it's very identical to that last, or very similar, almost identical. I don't know what I'm saying here. So go ahead and try it, and then check back and see how you do. But I'm just going to go through this one. So x times x is x squared. X times negative 2 is a negative 2x. And x times I is plus xi. Oops. And you're going to see the same terms canceling out. Your xi term cancels out. Your I terms cancel out. You get very similar steps, just like we did in that last problem. Okay, so you're not going to get the same answer. Oops. You're not going to get the same answer that we had in that last one, obviously, because we have different factors, but you get similar steps along the way, similar things canceling out. But anyway, back to the problem. Negative 2 times negative 2 is 4. And then negative 2 times I is negative 2I. And the last part here, negative I times x is negative xi. Negative I times 2 is a positive 2I. Okay, again, they're going to cancel. 2I, negative 2I. And the negative I times I, negative I squared, which again we know is going to be plus 1. We just did that in the last problem there. Let's bring this down. Y equals x plus 1. Let's see what we have canceling out here. Xi minus xi, 2I minus 2I. And again, like I said here, we have a negative. I squared is negative 1. So that's plus 1, double negative. That's going to be added to this 4 and make a 5. So we have x squared. We have a negative 2x right here. We got another negative 2x right here. So that's going to be a negative 4x. And then we have this 4 and another 1 right here is going to be a plus 5. All right, so y equals, now we're going to multiply the x plus 1 through. So we got x times x squared. So we have x to the third. And another thing you want to keep in mind, this says it's a third degree polynomial. That tells you that your highest power should be x to the third. Okay, if this is a third degree polynomial and you're ending up with an x to the fourth, that should be a pretty good indicator that you made a mistake somewhere. So just keep that in mind. I don't know if I mentioned that in the last video or not, but just a good thing to keep in the back of your mind to help you do some checking before your final answer. X times negative 4x is negative 4x squared. X times 5 is plus 5x. Okay, and multiply the 1 through. So 1 times x squared is plus x squared. 1 times negative 4x is negative 4x. And 1 times 5 is plus 5. We got one more thing to do. We just need to combine our like terms. X to the third. We have negative 4x squared plus x squared. So negative 4 plus 1 just gives you a negative 3x squared. And then we have 5x. I think that was a minus 4x. So plus 1x or plus x. And then we have this plus 5. Let me just check up here. Yeah, 1 times negative 4 was negative 4x. All right, so there's your final answer for that one. And again, like I said, we're going to go back to number 4. And I know fourth degree polynomials kind of sounds like there's going to be a lot more work to do, but there's really not, because it's actually easier to do. All right, so we're going to jump back to number 4 now. And again, if you need to see any of these steps, rewind it, look back through it, and see what we did, and you know, try to follow through it. All right, so excuse me. All right, this one says fourth degree polynomial with coefficients of rational coefficients that has roots of I and 2i. So that means the roots are I, negative I, 2i, and negative 2i. Okay, so that's how we're going to start it out here. Let me just slide down my first step here. In our starting point there, we have x minus I, x plus I, x minus 2i, and x plus 2i. So the nice thing about this, and I know I mentioned it in the video, the 653 video, was that if you recognize this, these are both sets of difference of two squares. So like x minus I, x plus I, that's the difference of two squares. So you could jump to x squared minus I squared. Same thing with the x minus 2i and x plus 2i. That's x squared minus 4i squared, or you could put 2i in parentheses and square that. I did the whole thing out for people that don't recognize that, so that you can see what's going on here. So let's just walk through the red part up here. So x times x is x squared. X times I is xi. Negative I times x is negative xi, and negative I times I is negative I squared, which again, we know this is plus 1 from the last two problems that we did now. The middle terms cancel out, and like I said, you end up with x squared minus I squared, difference of two squares. X squared minus I squared, middle terms cancel out right here. All right, this is what's going to happen in both of these problems, right? This and this cancel. Okay. Over here in this problem, x times x is x squared. X times 2i is 2xi. And then we take our negative 2i. We have negative 2i times x is negative 2xi. Same thing. 2xi minus 2xi. They cancel. So we end up with our difference of two squares again. X squared, the first one squared, x squared, minus the second one squared, so 4i squared. Okay, it's a difference of two squares. If you recognize that, it saves you a lot of time in that second step. Now this second one here, again, this is going to be a minus 4, and then I squared is negative 1, so this just ends up being a positive 4. Okay, so when we move this down here, okay, we have x squared plus 1, and then we have x squared plus 4 that we just had from that last part there. Okay, so if you look at this simplified to a much nicer thing. We have a binomial times a binomial, much fewer steps to distribute all this stuff through here. So let me show you what we have here. Distribute the x squared through. We got x squared times x squared is x to the 4th. Remember, we add those exponents. 2 plus 2 is 4. X squared times 4 is 4x squared. Then we have 1 times x squared is just x squared. 1 times 4 is 4. One more step in combining those middle terms. 4x squared plus x squared is 5x squared. And that's it. You're done right there. And like I said, even though it's a 4th degree, it might sound like it's more challenging and has more steps. It ended up being a simpler problem to do there. So again, try the homework problems. Let me know if you have any questions. Just send me an email or send me a comment on Google Classroom, and just let me know if you're having any problems with these.